Welcome to the deep dive. Ever wrestle with a huge problem and then the solution turns out to be, well, completely counterintuitive?
Happens all the time.
Exactly. And that's kind of the puzzle we're unwrapping today. We're diving deep into why, even with this absolutely exploding demand for AI compute, we might not actually need more data centers.
It sounds wrong, doesn't it?
Mhm.
But it's a really compelling argument.
It is, and it comes straight from a presentation by Dr. Jasper Zhang of Hyperbolic. They call themselves an AI cloud for developers.
Right, Dr. Zhang. He's got quite the background to make this kind of argument,
Oh,
actually.
yeah.
Yeah, I mean, think about this. A math PhD from UC Berkeley in just 2 years. Multiple gold medals.
Wow. Okay.
And then he applied that really rigorous efficiency thinking to AI and machine learning for market prediction. His whole thing is optimization, cutting waste.
So he's looking at compute demand through that lens.
Mhm.
Efficiency first.
Exactly. So our mission here really is to unpack his idea. How can optimizing what we already have tackle this massive compute demand instead of just building more and more?
Okay, let's set the scene then. Because the demand is massive, right? Every company, it seems, is trying to become an AI company now.
It's a fundamental shift, absolutely.
And that's driving this colossal need for GPUs and obviously the huge data centers to put them in.
hmm
I saw this McKinsey projection. They think by 2030, we'll need 4 times the data centers we have today.
4 times. That's staggering.
And here's the kicker. They say we have to build them in just a quarter of the time it usually takes.
That sounds almost impossible.
Right. The current capacity is around, what, 55 gigawatts?
Yeah, about that. And it's projected to shoot up to maybe 219 gigawatts by 2030. That's like a 22% growth rate every single year.
Just building seems like a tough way to meet that.
Well, it feels impossible if that's the only strategy.
Yeah.
Think about the cost, first off. That first Stargate data center, over $1 billion.
$1 billion, just for one.
Just for one. And then, getting them plugged in, the grid connection is incredibly slow.
Right, I heard about that. Wait lists.
Yeah, in Northern Virginia, a huge data center hub, there's a 7-year wait list just to connect a 100-megawatt facility.
In 7 years, you can miss the whole wave by then.
Pretty much. And then there's the energy use. Data centers already pull about 4% of total U.S. electricity.
4%, just data centers and GPUs.
Uh-huh. And that means significant CO2 emissions. So just building more isn't exactly sustainable.
So cost, time, power, environment. It's
Right.
hitting roadblocks everywhere.
And even if somehow all the planned ones get built on time, which is a big if,
Yeah.
projections still show a supply gap, over 15 gigawatts short in the U.S. alone by 2030. The math just doesn't work if building is the only answer. It can't solve it.
Okay, that's a stark picture, but here's the paradox that gets me. Massive demand for GPUs, everyone's scrambling,
Yeah,
yet you hear that loads of existing GPU capacity is just sitting there, idle. How does that even happen?
that's the crazy part, isn't it? It's the core of the problem. Deloitte actually found that enterprise GPUs, they sit idle 80% of the time.
80%. Seriously.
80%. Just think about that, doing nothing.
Wow.
And the market is super fragmented. You've got like over 100 different GPU cloud providers out there.
100. Okay.
So users are either struggling to find any available GPUs or they're paying through the nose for them.
Well, elsewhere, perfectly good GPUs are just offline.
Exactly. Just sitting idle in some data center or private cluster, it's a huge, huge mismatch.
Yeah.
A massive inefficiency.
So massive demand, but tons of supply is basically hidden or inaccessible, the ultimate matching problem.
Precisely.
So how does Dr. Zhang propose we fix this? Is this GPU marketplace idea the key? An aggregation layer.
That's the core concept, an intelligent aggregation layer. Something that brings all these separate data centers and GPU providers together, makes them act like one unified network.
Okay.
Hyperbolic, for instance, they built this thing called HyperDOS. Stands for Hyperbolic Distributed Operating System.
HyperDOS.
Okay. Think of it like a smart agent you install. You know, Kubernetes. Helps manage software across computers.
Yeah.
Well, this HyperDOS agent connects your GPUs, your cluster, into their big network. Makes your compute discoverable.
And that's easy to set up.
Apparently, yeah.
Yeah.
Any existing cluster, even just a MacBook or PC running micro K8s, you install the software and boom, you're part of their network in under 5 minutes.
5 minutes. That's really fast.
It is. And once you're connected, or if you're a user looking for GPUs, you get all this flexibility.
How so?
You can rent GPUs in different ways. Spot instances. They're like the super cheap last-minute tickets if you're flexible.
Okay.
On demand is your standard pay-as-you-go. And long-term reserves are for consistent access, like a subscription. You can even host your models directly on the network.
So different ways to buy depending on your needs.
Exactly. And they have this internal way of talking to it just to illustrate how it works.
Mhm.
They call their central server the monarch.
Monarch. Like the king.
Sort of, yeah. It's the brain, knows where all the available GPUs are. And the compute owners, the ones with the idle GPUs, they call them barons.
Monarchs and barons, okay.
So a user asks for GPUs, the monarch finds an available baron with the right stuff and sends the job there, keeps everything utilized.
Okay, let's unpack this a bit more then. The tech sounds smart, HyperDOS, monarchs, barons. But what does it really mean for someone struggling to find compute? What are the actual tangible benefits here?
Oh, they're pretty significant. First off, cost. The math modeling suggests something like a 50 to 75% reduction.
50 to 75%, that's huge.
It is. And to give you a real number, Hyperbolic's beta marketplace, they were pricing an H100 GPU at 99 cents an hour.
99 cents. What's that compared to, say, Google?
Google's on demand is around $11 an hour. Lambda's maybe 2 to 3 hours.
Wow, okay, that's a massive difference. How is that even possible?
Well, the theory behind it, as Dr. Zhang points out, it comes from math. Queuing theory, specifically MMC theory.
Queuing theory, like managing lines.
Essentially, yeah. But applied to compute resources, it uses sophisticated statistics to allocate GPUs super efficiently, minimize idle time, make sure supply meets demand smoothly. It's clever math reducing waste.
So the insight isn't just, let's make a marketplace. It's applying this deep mathematical optimization to the marketplace.
Exactly. It changes how you even think about provisioning compute.
Okay, massive cost savings. What about time? Does it save headaches there too?
Absolutely. Think about it. You don't have to vet dozens of different suppliers anymore.
Right, no more endless sales calls.
Exactly. No more trying to figure out who has what the real price is. You just go to the marketplace, look at ratings, find the best price, maybe check performance benchmarks they offer.
Streamlines the whole process.
Totally. Gets you to the actual work much faster.
Cost savings, time savings, both sound amazing.
Yeah.
But let's make it really concrete. Walk us through a real-world scenario. This is where it gets really interesting, right? The nightmare for a startup today versus how this marketplace approach flips the script.
Okay, perfect example. Let's say a startup needs 1,000 GPUs for a big training run.
Right. A common scenario now.
In the traditional cloud world, they probably rent those 1,000 GPUs for a whole year. That's often the minimum contract.
Okay, locked in for a year.
Now, what if, say, 3 months in, they suddenly need another 1,000 GPUs for a short burst? Maybe a month-long project.
Uh-oh.
Typically, they'd have to rent those 1,000 GPUs for another full year, too, just to get access for that 1 month.
So now they're paying for 2,000 GPUs for a year, even if they only needed the extra 1,000 for a bit.
Exactly. And then, maybe by month 6, the big training is done. They only need 500 GPUs for ongoing inference work.
But they're stuck paying for 2,000.
They're stuck paying for 1,500 idle GPUs they don't need for the rest of that year. It's incredibly wasteful, a huge cash burn.
Ouch. Yeah, that sounds like a startup killer right there. So how does the marketplace model change that grim picture?
It completely transforms it. So the startup still rents the initial 1,000 GPUs for a year, let's say. But in month 3, when they need that extra burst, they rent the additional 1,000 GPUs for just 1 month.
Ah, flexibility.
Total flexibility. And then, crucially, by month 6, when their needs drop down to 500, they simply release their 500 idle GPUs back onto the marketplace. Someone else can rent them.
And they stop paying for them.
Instantly. They only pay for what they actually use.
Okay, the cost comparison must be nuts then.
It's genuinely staggering. In that scenario, the cost could drop from something like $43.8 million down to $6.9 million.
Hold on. From over 40 million to under 7 million.
Yeah. It's roughly a 6x saving.
6 times.
Yeah.
That's not just trimming the edges, that's fundamentally changing the economics.
Exactly. And this is the key point. It's not just about saving money.
Right. What else does it unlock?
It's about increasing productivity. We know from scaling laws in AI, more compute generally means better models. So if you can get 6 times the compute for the same budget,
Yeah.
you can effectively increase your productivity by 6x.
So smaller teams can suddenly punch way above their weight.
Precisely. This really empowers startups, independent researchers. They aren't quite so reliant on the giant closed models from, OpenAI or Anthropic. They can afford to do more extensive training themselves, experiment more.
Fosters more innovation, more competition.
That's the idea. It levels the playing field somewhat.
So, stepping back, What does this mean for the bigger picture? This feels like it ripples outwards, doesn't it?
It absolutely does. Thinking more broadly, there's a huge sustainability angle here.
Oh, so.
Instead of constantly pouring concrete and energy into building new data centers, consuming land, we're talking about reusing and recycling the compute power we already have that's sitting idle.
Right, maximizing existing resources.
It's just a much more environmentally sound approach. Saves energy, saves land, reduces waste. And looking forward, the vision isn't just about raw GPUs either. The idea is these marketplaces evolve into like all-in-one platforms. They'll handle all sorts of AI workloads, online inference, offline batch jobs, complex training runs seamlessly. But then ultimately, that's what users need, right? A complete solution, not just access to hardware.
So, okay, if I'm distilling this down for you, the listener, the big shift is from just building more to smarter allocation of what exists.
Using it efficiently.
This GPU marketplace idea offers potentially massive cost savings by tapping into idle compute.
Huge savings, yeah.
And it's got clear environmental benefits too, using what's there instead of constant new builds. It really reframes the problem.
It reframes the solution, I think.
Yeah, good point. So as you think about this, maybe consider how this shift from just building bigger to optimizing smarter via a marketplace could really reshape the whole AI landscape. Could it truly empower the smaller players, the researchers, in a way we haven't seen?
And maybe take it a step further. Beyond just AI and GPUs, where else could this kind of marketplace or orchestration layer thinking be applied? Where else are we facing scarcity or massive underutilization? Well, the answer isn't just build more, but use better. Something to ponder.
Lots to think about. We definitely encourage you to continue your own deep dive into this fascinating topic.